Hello, my Algebra 2 students. New unit to start today, all about radicals and exponents. So to start us off, we have to talk about all the exponent rules that we probably already know, and if we've forgotten them, that we need to bring back into our memory. So we're going to list them out here. Rules that we want to be able to commit to memory here. So the first one, if I am multiplying the bases, so like a to the x power, or excuse me, x to the a power times x to the b power. If we have the same base, all we have to do is just add, oh my goodness. All right, multiplying with the same bases. If we have x to the a times x to the b, we're just adding those exponents. So it becomes x to the a plus b power. All right, rule number 2. If we're dividing exponents, so x to the a divided by x to the b power, then we're doing the reverse. We can subtract those exponents. So x to the a minus b. All right, let's go back to some of the ones with multiplying. If we have x times y, and those are both being raised to the same power, that's equivalent to if I have x raised to the a power by itself and y raised to the a power by itself. Same thing goes for if I'm dividing. So let's say I have x divided by y, and then both of those are raised to the a power. I can rewrite that as x to the a power divided by y to the a power as well. All right, what about if we have a power raised to another power? So like x to the a power and all of that raised to the b power. So in that case, instead of adding exponents, power raised to a power means we multiply. So this becomes x raised to the a times b power. All right, and then we have a couple other cases to consider. The next one, what if we are raising it to the 0 power? I'm hoping we remember this one. Anything to the 0 power is simply 1, no matter what the heck it is. All right, we have 2 left that are sort of the same rule, but kind of showing it 2 different ways. Sorry about all the shadows in here. Try to move into the light. There we go. This one, if I have x and I raise it to a negative a power, anytime I'm raising to a negative exponent, it's the same as if I take the reciprocal and then raise it to that positive exponent. So if I flip this over, meaning let's put x in the denominator, it would now be raised to the positive a power. So kind of that same little rule over here. If I start with a fraction, so let's say it's x over y, and I raise that to the negative a power, same thing. The fact that it's already a fraction means when I take the reciprocal, flip the fraction upside down, so y comes up top. Whoops, not a. Let me fix that. There we go. Y comes on top, x lands in the bottom, and now the whole thing would be raised to the positive a power. And then I can use this rule and expand and make it y to the a over x to the a and so on. All right, that kind of covers all the basics. We're going to keep the notes short and sweet. I want to try to hit maybe one of each, maybe 1 or 2 combo ones, and then we'll save the rest for class. So for our practice, the idea is you want to write each expression in simplest form with positive exponents only. And the directions will almost always say something like that, where leave all the exponents as positive values here. All right, so the very first one, if I give you x to the 10th times x to the 3rd, that's that first rule, adding exponents. So 10 plus 3, there's x to the 13th. And you can even picture this would literally be 10 x's written out, 3 x's, total 13, easy, done. All right. If we take the next one and we go x to the 10th divided by x to the 3rd, right? In that case, if we wrote them all out, 3 would cancel, and that's where we get the idea that we're subtracting. There's our x to the 7th. All right, third one. If I had something like 2 and then times x cubed, and then that raised to the, let's say, why not, 3rd power. This kind of covers 2 different ones in one example. Couple things. First of all, the fact that these are raised to the 3rd power, I can individually raise them to the 3rd power. So the 2 would get raised to the 3rd. The x cubed would get raised to the 3rd. All right, 2 cubed, that's just 8. This one here is where you can use rule 5, power raised to a power. We are going to multiply those exponents. So that becomes x to the 3 times 3, or 8x to the 9th power right there. All right, the next one, let's do something like, let's compare 2 for this next one. This is a good one to kind of point out here. If I give you 3x to the 0, let's call that part A, versus part B, the quantity 3x to the 0. See if you can figure that one out. So the rule, x to the 0 is 1. Here, just the x is raised to the 0. So this would be 3 times 1, which is 3. Over here, the whole thing's being raised to the 0 power. So the whole thing just turns into 1. So that tiny little difference makes a difference in that answer there. All right, these weird shadows are almost creepy. All right, we got just a couple left to talk about. For number 5, let's see. What rules did we not hit? Ooh, the rules for 7 and 8. Those are definitely kind of key ones here. All right, if I give you guys, x raised to the negative 5th power. All right, something as simple as that really just means, all right, flip it on over. X goes to the bottom, and now it's raised to the positive 5th power. Done, easy. Let's make example 6 a tiny little extension of that one. Let's say I now make it 3 times x to the negative 5th power. All right, well, we learned our lesson back in example 4 that if there's no parentheses, the exponent only applies to the base right here. So this whole thing is not raised to the negative 5th, just the x. With that being said, this would then become 3 times 1 over x to the positive 5th, or I'd end up with 3 over x to the 5th power. Ooh, sometimes that can be tricky to understand. So make sure, if I said versus quantity 3x like that to the negative 5th, that guy would then be 1 over the whole thing raised to the positive 5th. Then I'd have to figure out what the heck 3 to the 5th power is. Let's see. 3 raised to the 5th power, that would be 243 x to the 5th. 2 totally different things. So just make sure that we understand the difference. If it's not in the parenthesis or it's not being applied to, the exponent doesn't apply to it, then it stays out front, minds its own business, multiplies by that answer. All right. Next one here, if I then give you a fraction. So we're going to make this one kind of the most complicated one we've seen yet. So if we turn this into 2x and then over 3y squared, raise that whole thing to the negative 2nd power. All right. Everything is being raised to that negative exponent. First rule I would probably want to apply here then is flip it on over. So it's already a fraction. Everything in the denominator comes up top. Everything in the numerator drops to the bottom. Now I can raise that to the positive second power. Now I can use my rule from kind of like rule 3 up top, that everything in here is going to get squared. So this is now 3 squared, y to the second squared, 2 squared, and then x squared. All right, let's do it. 3 squared, 9. Y squared, squared. Sounds weird, but power raised to a power, I multiply. 2 to the second power, it would be 4. And then x squared literally is x squared. All right. I think that's a great place to stop. We've hit a little bit of everything. We'll pick up with this tomorrow. Thanks, guys.